Welcome back to our deck building roguelike card game tutorial series in Unity. Today we're going to be working on making a dynamic arrow that follows the mouse from the card position. In the last video we worked on the card movements, and I did end up having to make a change to that script, specifically to the OnDrag method, which you can see here is the changes that I made. I also added some lerping to kind of added a more natural feel to the movement, so it's not just snapping across the screen. So that's what we're doing here. And yeah, that should get you ready for today's lesson. Let's go ahead and hop right into it. The very first thing that we need to do is we need to make two prefabs. So first, let's go on our canvas here. Let's right click. We're going to create a new image asset. We're going to name this Arrow Head. Okay. We are going to set a few things here. The width of it is going to be 1, and the height is going to be 0.5. And then we're going to take a look at our sprite here, and we're going to set the sprite to the right bright with no background. Okay, hop over to our scene. Let's take a look at our right bright real quick. And then we're going to drag this down here, make it a prefab. Then we're going to right click here on our canvas. We're going to create another image. We're going to name this one Dot. And its width and height are going to be 0.2 by 0.2. And its sprite is going to be this background sprite right here. And we're going to drag it down and save that as a prefab. Now we can delete both of these from our scene. Now let's jump into our arrow prefab. Okay, and we're going to go ahead and set the color to black. And we're going to go ahead and set our anchor and pivot. In order to set the pivot also, we're going to hold down Shift. You see that little blue line that's going to pop up. We're going to click on the middle right. Okay. Over here, we're going to set its position to 0, 0. And then we're going to go right click and duplicate. It should go and make a child of the exact same object. And we're going to change the color to white. And then we're going to set the scale to 0.8, 0.8. And then we're going to go in here and we're going to do Shift and reset the pivot and anchor to the center. We're going to change our position to 0, 0. So it looks like this. What this is doing is basically giving it a little bit of black outline. I know it's not perfect, but it's going to look great for what we're using it. Next, let's hop into our dot prefab. And we're going to do pretty much the same kind of setup. So we're going to first change this to black, and then we're going to duplicate. We're going to set the scale to 0.8, 0.8, and we're going to set the color to white. And oh, I did 0.7, that's why. There we go. And that's all we need to do with that. We're going to do something a little bit different here with this script. So I've actually written the script before for another project, and I'm bringing it over to this one. And the last time I did this, I just gave you all the script and the details of the video. I really want you to learn something from this video because this is a very complicated script, and there is a lot to learn from it. That's the reason why we're doing this a little bit differently, is that instead of me typing everything out, I'm going to be copy-pasting it. And then, while I'm explaining what the script is about, you can take that time to copy the script over into your own script. So the very first thing we're going to do is we're going to go down here. We're going to right-click, Create C# Script. And we're going to name this Arc Renderer. And let's go ahead and open that up after we finish compiling. So the first thing that we need to do is we need to adjust our namespaces that we're using. So we don't need system.collections, and we will be using Unity Engine. We will be using system collections generic as well. This one is inheriting from mono behavior. And we will be using the start method here. But I hate that comment. I don't like it. And we're going to take out that comment as well. We will be using the update method as well. So, very first thing that we have to do here is we're going to get our variables and initialize them. So let me go ahead and copy those over, and we can take a look at that. Before we go any further, you can see here I have comments on each of these lines. These comments I have here are because I'm going to explain to them what they do. But I do not think you should comment like this. I think that commenting like this is bad because it means that your code's bad. What I mean by that is that if your variables are not specific enough and not named correctly to where you can just know what they are by looking at the name, then you're naming your variables wrong. Okay? You want specific names for your variables so you can look at that and just automatically know what it is. You don't need to comment like this in every one of your scripts because you already know what it is by just looking at it. And the people that come and look at your script later are going to know what it is because you named it specifically. It's really important in a professional environment to not comment on every single tiny thing because if I am working in a professional environment and I'm looking at someone else's code, I'm not looking at the comments usually unless they're super, super detailed and specific, because that means that it's going to be a complex topic that they're going to be going over in the code. But usually I don't look at the comments, I'm looking at the code, because the code reads like a sentence, usually. So going through our variables here, we're not using any classes that we haven't seen before. We've got our arrow prefab and dot prefab, which are game objects. And then we have our pool size, which is just an integer. We have a list of game objects, which is our dot pool. And then we have our arrow instance, which again is a game object. We have our spacing, which is a float. Arrow angle adjustment, which is also a float. Dots to skip, which is an integer. And a vector 3, which is arrow direction. A pool is what's going to store a group of objects that are going to be reused over and over again. So we don't have to keep instantiating the same objects repeatedly. It's good to have pools when you have a repeatable object, like, say, a bullet. If you're repeating that over and over again, it doesn't make sense to create it every time and destroy it every time. It makes more sense to create it, activate it, shoot it, disable it, and store it for later use. It's a lot more efficient that way. So our pool is going to store a group of our dots that we have here. Okay, let's move down to our start method. So we start off pretty simply with creating our arrow instance, and we are setting its position to 0, and we are, instantiating the arrow prefab. And we're setting it to 0 by using this right here. and we're using vector 3.0 for the position. Now, vector 3.0 is the exact same as typing out new vector 3, 0, 0, 0. It's also going to be the same for vector 2. There's actually a lot of little shortcuts like this for vectors that are commonly used. And then finally, we're going to call a new method that we haven't created yet called InitializeDotPool. That's going to end up creating our dots. So let's go ahead and make our InitializeDotPool. Oh, by the way, if you ever type something wrong and it's in the wrong format or add too many tabs on something, or delete something and want to decrease its tab, you can right click and do Format Document, or press Shift-Alt-F. And it'll automatically format that for you. If you're using Visual Studio Code, of course. So this method is pretty simple. We have a count that is passed in this, which you can see here is our pool size, which you can see here is set to 50 initially. And so for each I, where I equals 0, I is less than 50, and we're incrementing once every run through, or every loop. We're going to create our dot from our dot prefab. We're set to 0, its rotation is 0, and it's transformed to the transform of this object that has the script. This is important. Anytime you see in here that I'm just saying transform, like right here, I'm just saying transform, this is getting the position of the object this script is attached to. You can adjust that for your own projects if you know that in the future. After we instantiate it, we're also storing it with the variable dot, and then we're setting that dot to inactive, and we're adding that dot to the dot pool. Pretty simple. The very next thing that we have is our update method. And this is very straightforward as well. So during our update method, we grab and store the position of the mouse and ensure that the Z value of the mouse is set to 0. This can be wonky sometimes, especially for 3D environments. So we'll make sure we're setting it to 0. Next, we're creating some new vector 3s here and storing them. First, we have our start position. And we're grabbing the position of the object holding this script. So again, you can adjust this for your own project if need be. And then we have another vector 3, which we're going to actually create a method to calculate the midpoint between our start position and our mouse position. And then we have another method called UpdateArc that's going to update the position of our dots and activate them as our arrow grows and shrinks. And then we have PositionAndRotateArrow, which is also a new method that's going to rotate the arrowhead of our arrow. By the way, I think that this line right here is a good example of what I mean by a line of code basically being a sentence. So we want to get the middle point and set it equal to the middle point of start position and mouse position. It reads exactly like a sentence would, right? So there's no need to put a comment on this because our line of code is already basically the same as a comment. All right, let's get started on writing out that CalculateMidPoint method. So right here, let's go ahead and make some space for our new method. And paste that in there. Format document. Alright, so we have a CalculateMidPoint, and it's going to take two vector 3s, the start and the end of our line here. So very first thing is we're going to take our start and end, we're going to add them together, divide it by 2, and that's going to be our midpoint. But this is going to be an arc, remember, so we don't just want a line. And we also want it to be like a dynamic line. Okay? So we get our arc height, and we get a new vector 3, which is going to be the distance between our start and end. And we're going to divide it by 3. So that means that this point's going to be kind of like a third of the distance between the start and end. And we're going to add that to the height of our arc. And then that's going to modify our midpoint, kind of push it up into the air a little bit. And then that's going to return our midpoint here. So the very next method that I want to work on is going to be our UpdateArc method. So this is going to be like the huge, driving factor of this script. So I want to put it pretty high up. Not that high up. I don't want it after the start. I want it up after the update here. Okay. And this is the UpdateArc method. So this method is responsible for activating, positioning, and moving the dots to form an arc. It also determines the position for the arrowhead's rotation. And so let's go over this line by line. So first, the number of dots required for the arc is determined by dividing the distance between the start and the end points by our spacing value. And then we are going to use mathf ceil_to_int, which takes a float and it's going to round it up to the nearest integer. Okay? Next, before positioning the dots, we're going to make sure that we do not exceed the required number of dots, which we get here, and we don't exceed the number of dots in our pool count. Again, our dot pool is the pool of our instantiated dots. All right. Next, we're going to start setting up for a Bezier curve. A Bezier curve is used to create an arc. A Bezier curve is not exactly an exponential curve, but allows for smoother and more controlled curvature by adjusting the highest point of the curve along the line. You'll understand more what I mean by that whenever we look at the end result of this. The Bezier curve requires 4 inputs for our function that we have here that we will create in just a moment. It requires the start, the middle, the end of the line, and the parameter t. And t is going to represent a position along that line. So basically we're giving it everything that we need to create the line, and then we're looking at a specific spot along that curve that we want to get the coordinates for. Okay, and that's going to return a vector 3. Alright, but first we gotta get our t. So the parameter t must always be between the values of 0 and 1, because 0 is going to represent the beginning of our line, and 1 is going to represent the end of a line. So we calculate t for each dot by taking I and divided by the number of dots, which has been converted into a float. And then we take that t, and then we use mathf.clamp to ensure that t is not outside our 0 and our 1. This is because, again, we want to stay within that 0 and 1. It's very important that we stay within that 0 and 1, so this mathf clamp ensures that that happens. So then we input our start, mid, end, and t, and we get a vector 3 as our position. And then to provide space for the arrowhead at the end of the line, we also skip positioning some dots at the end of the arc. So because our arrowhead is bigger than our dots, we want to make sure that we actually have space for our arrowhead to display fully and not be obstructed by one of the dots. So we have our dots to skip, which again is set up here. And that can be changed depending upon what we need for our arrowhead. So if I does not equal the number of dots minus the dots to skip, then we're going to get the I dot from the dot pool. We're going to set its position to the position we got from our BezierPoint function up here, our method up here, and then we're going to set it to active. Finally, in this section, if I equals number of dots minus dots to skip plus 1, and I minus dots to skip plus 1 is greater than 0, then we set that dot's position to our arrow direction. We're going to use this later to determine the direction of our arrow, and you'll see what I mean by that when we get to that. Just put a pin in that and remember it for later. Finally, we're going to go through our number of dots we're going to start with the number of dots that we require minus our dots to skip, and we're going to deactivate the dots that we don't need. That's all we're doing here. It looks kind of complicated, but all we're doing is in our pool, make sure that the dots that we are not using currently are deactivated. Because remember, we're not deleting those dots. They're still there. They're just set to active or deactive, depending upon if we are using them for the line at that moment. I hope all of that makes sense. If you have questions about that, please post it in comments or join our Discord, and we can discuss it there. Next, we're going to create our CalculateBezierPoint method. And so we're going to make a new method, and we're going to do it after our CalculateMidPoint. Okay, and I am not a mathematician. I understand what this does, but I don't understand how to explain it to you. So if you want to understand how this function works, just look up a Bezier point or Bezier curve online, and you'll get a much better explanation than what I can give you here in the short time we have for this tutorial video. So for now, copy this method and put it in your script. I'll give you all a few seconds to take a look at this now. Okay, let's go ahead and move on. So we actually only need one more method here for our script. And so that method is called in our update here. You can see position and rotate arrow. So to do that, we can come down here, make some space after our UpdateArc method. And here we have our position and rotate arrow method. This method is responsible for updating the position and rotation of our arrowhead. We start with setting the position of our arrow instance to the position that is passed into the method. You can see we're getting that mouse position here, and we're passing that position here into our method for use. After that, we get our direction by subtracting two vector 2's. The position that is passed to the method and the arrow direction, which is set in the UpdateArc method. Now we start doing some funky math stuff. Mathf.atten2, what that does, it converts an x and y of a point into radians and can return a value between -pi and pi. When we then multiply it by mathf rad to degree that converts the number from radians to degrees. And now we have an angle. Alright, next we do some adjustment to our angle, which again, we're setting that adjustment up here. And so then we take the rotation of our arrow instance, and then we do quaternion angle axis. What that does is it takes two inputs. The first is our angle, and the next is the axis we want to change. The way that this works is that any axis that has a 1, that's going to be the axis that we're changing on. And so we use vector3.forward, which is the same as 0, 0, 1. So we are rotating on the z-axis, which is what you want to do for a 2D project. And that's it for the script. I'm going to take a moment and I'm going to scroll through the script for y'all to just review it and make sure it matches what you have. Alright, hopefully that all matches to what you currently have. If not, go ahead and use the chapters for YouTube to find the section that you missed and review it. So we are now back in our game. We're going to go to our card prefab. We're going to double click it to open it. We're going to go to our play arrow. We're going to add component. We're going to add arc renderer. Now we're going to drag our arrowhead into our arrow prefab. We're going to drag our dot prefab into our dot prefab. Alright, now that that's all set up, we get to test it out. Let's go ahead and hit play. Alright, and now that we're in here, so I've hit play, I've got my cards. I'm going to click my card, drag it up. You can see we've got our arc showing up. Now obviously our little arrow is a little bit messed up, so let's fix that. We can do that by just going over here to our arrow angle adjustment, but we actually need to do it and test it in our scene, so let's go on to our prefab clone. Click our play arrow, and we're going to set our angle adjustment to 180, because it seemed about right. Is that about right? That looks about right. Now, I'm not quite liking the spacing yet, so I'm going to change our spacing to 40, actually. And I like that spacing a lot more, but now we have an issue of this dot showing up over the arrow. So I'm going to change our dots to skip to 2. Test that out. And that looks pretty much perfect. Yeah, it looks pretty perfect. After figuring out what I want, I'm going to jump back. Or first I'm going to stop the game. Then I'm jumping to my card prefab. I'm going to change my spacing to 40. And my arrow angle adjustment to 180. And my dots to skip to 2. Now I can play. And I should be able to, yeah. There you go, looks perfect. So before the next video, this homework is going to be a bit more abstract than previous ones. What I want you to do is, on a piece of paper, or a note-taking program, whatever, I want you to draw out a quick little diagram of how you think we can utilize or play these cards. Like what I mean is, like, are we going to put these cards in a grid somehow? RTS game? Is it going to be like they do direct damage to something? Are they going to spawn creatures? Things like that. I want you to kind of do a quick iteration of what you think the game flow and the game loop are going to be for this card game. Now you might think, oh hey, this is useless. He's just going to do whatever he wants. He's going to use his own idea for this game, which is true. I am. But it's not useless because it's practice. It's practice for you to learn how to visualize the loop of your game before you put it into the game. It's a very useful tool to have. So that's it for this episode. Hopefully you enjoyed it. It was a little bit different when it came to the script this time for how I went through it. I hope that it worked for you. If it didn't, please let me know. If you like this better than the previous ones, please let me know that as well. I'm sorry if my voice sounded a little bit weird, or if any of my coughing came through. I have been sick, and that's why this video took so long to come out from the previous ones. I'm finally starting to feel better, but my throat is still a little bit messed up, especially if I talk a lot. I already have a good idea of what I'm doing for the next video, so I hope to have that done fairly quickly. And yeah, that's about it. I'll see you next time.